Welcome to the Bearded Tits podcast, the nature-based show hosted by me, Jack Perks. Each week I'm joined by a guest from the world of wildlife television, art and science. We take a light-hearted look into what makes these people tick and connect with the natural world so strongly, with new episodes out every Tuesday. In this episode, I'm chatting to German biologist Katrin Linse, who has spent 25 years researching biodiversity and in particular looking at what's living deep in our oceans with the British Antarctic Survey. So it's going to be really interesting. It's a subject I know very little about, and I can't wait, if you excuse the pun, to dive in and find out a little bit more, and in particular about deep sea gigantism, where creatures are getting to enormous sizes from what their shallow cousins would, and it's just an incredibly alien world down there, something that Katrin is an expert in. Here's our chat. Well, welcome to the podcast, Katrin.
So thank you, Jack, for inviting me to talk to you today.
No worry. Am I getting your name right? I'm terrible with names. Is it Katrin? Is that what you prefer?
Yes, it's fine.
Yeah. So I've had it before where people have been like, no, you've not anywhere close. So you've just been on quite a special trip. You've just gotten back from that. So where did you go and what were you doing?
We went to the North Atlantic on an expedition called Ice Diva because we wanted to connect work we've done in the past around Iceland to an expedition called Diva that was done in the deep South Atlantic, south end of Africa and South America. So this time, the weather made us work around the Azores and north of Madeira, because anything further north towards Porcupine Abyssal Planet Island was hit by big storms.
Not ideal.
No, not ideal if you want to work on the seafloor and have equipment hanging on a rope for thousands of meters.
So you were taking samples, were you?
Yes.
Yeah.
Our idea was to study the animals that live on the seafloor in the abyssal deep sea. And this is the waters 3,000 to 5,000 meters below the surface.
Incredible.
So it's deep abyssal plains and unknowns that you find there.
Isn't it true or relatively true, every time someone does one of these trips in a submersible or even if it's a sampling, you're coming up with new species?
Yes, and on our expedition, we were looking at animals that you can see with your bare eyes, as well as myofauna, which is the animals that are less than a millimeter in size. And we had some experts on board. And our friend and colleague Alex is working on gastrotricha, some tiny animals. And he found a completely new genus of the group. It's like genus is when you think humans are called Homo sapiens. Homo is the genus, and this is a group that's different. So it's like chimpanzees are apes like humans, and they have a different genus. So it's a really big thing in biodiversity research to find a new genus. He was extremely excited.
Yeah, I bet. Well, it's not. I'm guessing it's not that common to find a new genus all the time. So that's great. And it's interesting that you mention the small stuff, because obviously what we're going to talk about today is the opposite end, which is the bigger stuff down there. So we'll start off with the basics. For people who don't know, what is deep sea gigantism?
Deep sea gigantism is when an animal group that we know from the shallow waters from a certain size is developing a much larger size when it lives in the deep sea. And that can have various reasons why they grow that large. In some animals, it can be because they just grow to a much larger age and continue growing. In other animals, it can be that the environmental conditions in the deep sea, and in some areas in the deep sea, we have a much higher percentage of oxygen in the waters than we have in the shallow waters, that the animals can use this extra oxygen to grow faster and larger.
Because I guess you'd think being bigger and what are the advantages? I mean, you've listed a couple there, because I guess, I don't know if it's always the case, because if you're bigger, surely you need more food. But I suppose a lot of these animals have quite low metabolic rates. So presumably they just have one, some of them, not all of them, obviously, but some of them just have one meal and they can last a while. But one springs to mind, is it gulper eels? Are they the ones with the huge mouths and they can eat one meal and last them for a while?
Yes, it can last for months on end. And the deep sea is a habitat we don't really know how long it lasts, because if you want to work in the intertidal or in the shallow water, you just go out on the shores and pick the animal up and bring it back into your aquarium or your shallow water university lab. But with the deep sea, it's different because those animals live under a completely different pressure than we have on land. So especially the fish like the gulper eels who have swim bladders, if we bring them up from their 2,000-3,000 meter depths of water, the air will expand. Like the same if you have a diver who goes up and doesn't breathe out, their lungs expand.
Yeah.
And the bubbles in the bloodstream and they get the diver sickness. It's similar with the fish. Their air bladder expands and that kills them.
So in theory, the only way to really study these animals alive is to go down there, I guess. Is that right?
To go down and look at them. And even if you have invertebrates, these are the spineless animals, for example, Horaceurians or little snails, little clams. You can bring those up and some of them happily live in our aquaria. But something in the metabolic rate, something in the way they feed and they live is changed. So we don't even know how they survive. And if what we measure when we measure them in the aquaria back home is their normal rate. So this is why we have started to use special technologies with aquaria under pressure in pressure tanks to keep them back to the pressure they had when we collected them and even collect them in those pressure vessels, so that we can have an idea on how fast they live, how fast they consume food, how often they need food. We just know in some areas they have food once and then might not feed for a very long time.
Is it the isopods, the ones that look like big wood lice? I know that's a very oversimplification, but because some of those are huge. I've seen like some of the
Actinomus giganteus.
Is that the species, is it?
That is the largest isopod in the deep sea, which can grow to 0.5 meter in size, is the largest specimen. And they actually, Batinomus looks very, very similar to our wood lices in the gardens. And isopods are brilliant because it's a group of species that brood the youngsters. So the females on their legs, when they become fertile, grow special plates underneath their legs that form a brood pouch. And this is where the eggs are being stored and where the youngsters develop until the youngsters can crawl out. And even when they are young and want to be protected, they go back into mummy's brood pouch. So almost similar to a kangaroo. And this is in an invertebrate.
I was going to say, you don't hear about parental care in invertebrates very often. So that's really...
No, the isopods or the pericarite crustaceans, the group the isopods belong to, all do that. And it's very fascinating. And when you have a little Bathydomus, when it is hatching out of the egg, it's almost 5 centimeters long. So it's longer than the largest isopod we have around the UK shores. And that is the baby.
Yeah, it's crazy how big some of these things get. I suppose the most famous examples are giant squid, aren't they? And people, popular culture and whatever is branded. I remember for a long time, being in wildlife filmmaking, no one had filmed one alive. And then I think maybe the last 10 years or so, people have caught glimpses on camera. Go on, sorry.
It was a collaboration between the Japanese who wanted to film the giant squid and American scientists who thought that the squid is an optical animal. They have big eyes, so we know they are using some of the bioluminescence in the deep sea to hunt. So they developed this light-emitting ball that they called Medusa. And when Medusa was taken into the deep sea and they had ROVs or submarines around it to monitor, they suddenly then attracted a large squid first and then one of the giant squid who they filmed live for the first time. Stunning. It's like we get tiny, tiny glimpses, and it's more a chance. It's with this new technologies going into using the senses those deep sea giants have, which we're just starting to realize what senses they have. We can go down, track them, and see how they actually look and move in life. Because before we only knew them when they had died and washed onto shores or by accident being hooked up on a fishing gear.
Am I right in thinking they've got the largest eye of any animal, giant squid?
Might well be.
It might well be, yeah. I'm sure I read that somewhere. And of course, there's the slightly lesser known cousin is colossal squid, aren't they? I suppose once you've used giant, you've got to come up with a better name. So someone had to think of that quite quickly. But I think colossal squid are not. They're not as long, but they're heavier, aren't they? They're still a very big, gnarly-looking squid.
Yeah, I think the colossal squid size-wise are similar, but the colossal squid has a larger body and shorter arms.
Right.
And this is why it looks stockier and shorter, but it's still gigantic.
Yeah, they've got hooks, I think, on the tentacles as well. I remember reading somewhere.
Yes, they have hooks on all the tentacles, going from the tip of the tentacles all along them to the main body. And all of these hooks, they can be quite big. They are twistable. So they can turn them 360 degrees. So they are very, very flexible. And if they find prey, or if they find their food, because it's hard to find food in the deep, they can really latch onto it and holding on.
Wow.
You don't want to come close.
No. I think, if someone gave me the choice between a shark and a big squid, I'd take the shark any day. I wouldn't want to tangle with
I agree with you completely.
Yeah, it's not something that I would want to encounter. Well, I would. I'd love to see one, but maybe not one with scuba gear on. You mentioned earlier about sampling the creatures. So how do you go about sampling them? How do you catch an animal that is thousands of meters down in this deep sea?
Well, we have different ways nowadays. The old-fashioned way is that you send equipment down on a long steel wire, and then you have what we were using is something called an epibentic sledge. It's 1 meter wide and 3 meters long, and has a very fine mesh net at the end. So we collect the tiny animals that are, as I said, between 1 millimeter and 3 centimeters. Or you send kind of fishing troll down that is 2-3 meters wide and has a net of 6 meter length with 1 centimeter mesh size. And it's weighted, so it goes down to the seafloor. You troll it along. So this time on the expedition, to get one of my nets back, it took 7.5 hours between the equipment leaving the ship and coming back. Wow. And then you see the sample you take, and then you need to wash it and clean it and sort the animals. Or you send a grab down, so something that goes into the seafloor, grabs, penetrates it, and brings it, almost like the digger shovels that you see on the building sites. And it comes back with a part of the sediment, and then you see who lives in the sediment. And the modern technologies are the submarines or the remote operating vehicles, where you send, especially I've been on expeditions where we used remote operating vehicles to go down to the seafloor and find the animals and then pick visually on who you want to collect. And then you never know what you encounter on the way down.
No. Do you ever come up empty-handed? Is it pretty good success rate, or do you ever, do all that and then nothing comes up?
When you go down and send something down, something will come up.
Yeah, okay.
Something will be there, and it might be tiny. And you have different areas where you have a lot of life in the surface waters. At some point that will die and go down the water column and provide food for the seafloor. And if you have a lot of food on the top and a lot of life on the top, and that sinks down, you have a lot of life on the seafloor, because the animals need food. And then when you go down, you can bring hundreds to thousands of animals up, but all really tiny. They all fit into a 1 liter volume jar of sampler. This time we had stations in this abyssal area where you have those big blue areas of clean water, where you don't have big phytoplankton and zooplankton masses in the upper water. So you have less food on the seafloor. And so our samples came back with a lot of sand and mud, but not very many specimens. So each of those is very valuable to us.
And what kind of depth would you say deep sea gigantism starts to become more commonplace? I mean, I guess it's hard to quantify it exactly, but at what depth are you seeing animals starting to adapt to living in kind of darkness and that environment?
This is where a hard question, because you can have really gigantic jellyfish see them in 200-300 meter water depths, but they can also occur the same species in 1,000 or 1,500 meter water depths.
Right.
So often it is when you go off the continental shelf break, which is deeper than 200 meters, that we come into the deep sea. And then you can encounter those gigantic animals. We have one exception on that, and that is the Antarctic, where it's very cold and you have a high amount of oxygen in the water, where you already can find these gigantic animals in groups in the shallower waters. A good example are the sea spiders in the British shores. They are tiny. They are about 2-3 centimeters maximum in size, and their legs are as thin as one of the thinnest sewing needles you have. If you go to the deep sea, you can find some that are as big as dinner plates. From their leg span can be 45, 50 centimeters.
Wow.
And if you go to the Antarctic, you can find these 30 centimeter long sea spiders already when you go out for a dive. And you find them on an expedition. We went off Iceland to the deep sea in 2,000-meter water depths this summer and had an ROV taking videos for us. And suddenly we had those 30 centimeter large sea spider there, but again in the deep sea. So the really cold and really good oxygenated waters are the ones that help gigantism.
You don't get many fish in the Antarctic, do you? Isn't that something to do? I can't remember the exact reason, but you don't get as many fish there, do you, say, compared to the Arctic?
Well, we do have fish in the Antarctic, and we even had global fisheries until the 1980s, but it's a completely different type of fish. The fish in the Antarctic does not have red blood. They have white blood, and they have adapted to the cold water. So it's a very special clade of fish that live in the Antarctic. So you don't have your normal cod, your normal herring, your normal eels. And we have only a few rays, and so far no shark have been found in the Antarctic.
Did you say their blood wasn't red?
No, their blood is white.
Wow.
And because of the high oxygen in the waters, they don't require the hemoglobin, our red blood cells, as we need, or the fish and the animals need them in the other waters.
That's incredible.
So, yeah, it's one of the really special adaptations the Antarctic animals developed over the 23, 30 million years they have been disconnected from the southernmost continents. And within that polar front, that fast-moving ocean circle that keeps the cold in the Antarctic.
Am I right in thinking these fish have some kind of antifreeze in their blood as well?
Exactly, they have antifreeze in their blood. Yes, that's the special Antarctic ones. And so we do have them. We do have fish in the Antarctic, and in certain areas, they seem to be quite common as well. But it's very different fish from their taxonomic ways, from their systematics, to the fish we have in the Arctic or in our British shores.
Very, very specialist species.
Yes.
And I guess it's amazing when you think about all these weird and wonderful things, fish with clear antifreeze for blood. And there's all these things that prop up in urban legends and whatnot. And one of the things I read online was of something called the blop.
Yes.
I don't know if you've come across this, but I guess
the
for people...
hydroacoustic sound.
Yeah, so for people who maybe aren't familiar with the bloop, can you just say, well, we don't know what it was, but can you kind of just explain a little bit about it?
Yeah, it's when you have, I say in the 80s, it became really familiar to listen to the song of the whales and the song of the humpback whales. It was the first times that even the normal audience were able to listen to sounds in the sea and recordings, and you could realize whales are talking to each other. And at the same time, especially the military, were recording sounds. And anybody ever watched Hunting Red October will hear that you can identify certain animals or machinery by their sound. And then there was this bloop, this weird hydroacoustic sound recorded that nobody can explain what it is. And we have no idea what it is made from. It doesn't sound human-made. It sounds it's produced by an animal, but we don't know which animal is producing the sound.
Because it was incredibly loud as well, wasn't it?
Yes, and at a frequency that they say it's something large, but we have no idea. And this is where you compare it with the recordings of the blue whales, of the minke whales, of the orcas. We know of so many sounds different whales do. But even in recent years, new whales have been discovered, and we have no idea how they communicate. So the bloop is one of the big questions that is still open to discover.
And I think that's one of it's probably one of the things that drives you to keep going out and exploring, because there's so much to discover. And I love that. Yes. In all, like, we don't know exactly what it was, but chances are some big marine animal deep down there is making a very large noise, which is a little bit exciting, I think.
Yes, because we started growing up as children knowing about these myths of the giant squid and the giant kraken, which had gone for hundreds of years through the myths of the seafarers. And then hundreds of years later, for the first time this century, we were able to see one with a camera. So we have huge animals that live in the deep that we don't know that they are there. And it's just the large ones. And then you can estimate how many small animals we don't know about. We have so much water around the Earth and so deep waters. And when you are there, even in a submarine, you can only see about 2-3 meters to your side and 5 to 10 meters to your front. So you have no idea what is around you. It's not like if you go out and walk in a forest, you can see for dozens of meters. If you're standing on a hill, you can look out for kilometers. In the deep sea, you can't. So we can be missing so many spectacular animals that are there.
Is it quite claustrophobic, or do you kind of find the opposite? Is it quite exciting?
I've never been in a submarine.
Oh, you've not? Sorry.
I would not go in a submarine because I would feel claustrophobic.
Yeah, I don't
blame. I can go into a dive chamber, like a rehabilitation chamber for training reasons, because I know I'm out 20 minutes later. But I wouldn't go for hours on end in a submarine. I prefer to use a remote operated vehicle and sit on top in the operating room on the vessel and look at the images the camera sent up and then get really excited.
Yeah, I can't fault you there, Katrin, to be honest. I mean, like, I do dive and stuff, but I'm not sure I'd want to go. Well, part of me would, part of me wouldn't. I don't know. I don't know if that opportunity will ever be given to me, but part of me would.
Yeah,
would
I turned it down.
Yeah, and obviously that's it. The deep conjures up so many ideas, and your mind can run wild. And I love some of these conspiracy theories, or maybe they're not conspiracy theories, on some of the creatures that live down there. Like one of the, whenever you watch Shark Week on Discovery, they always mention about Megalodon, the kind of very large, great white looking shark, potentially living down there in the deep. And I know we might be bordering on fantasy here, but I wondered if there was any merit to that, or is it just nonsense?
We know they existed.
Yeah.
And we don't know what is existing in the deep. The only thing I know, when recently there has been a lot of research and samples taken in the tropical Pacific Ocean around the manganese nodule fields. And I have found quite a lot of megalodon teeth. So far, all the megalodon teeth that were found are fossilized. So they are millions of years old.
Yeah.
And because you can, when you find tooth, you can test their age. And so far, no recent one has been found.
No, that makes sense. I mean, from what I'm not an expert on them. From what I gather, their main diet was whales, and they suspect one of the reasons they went extinct was because whales moved further north to colder waters, and Megalodon was a warm water shark. I think that's the leading theory as to why they went extinct. But again, in some ways, I don't know if I'd want to be. I'd be a bit more nervous if I was scuba diving and Megalodon was potentially down me. Although I'd just be a toothpick to one of those things. So I think they're that big.
We once sent the British remote operating vehicle Isis down in the Southern Ocean, and she had just come back from a large maintenance, and it was her first dive, and so we were all a bit nervous. And in around 280 meters, we had this large arm going past the video screen, and we knew what we were seeing was 1.50 meters wide on the screen, and it was going past and past and past, and we were still going lower. So the RV was going down by 30 meters per minute. So quite faster than you would dive down.
Yeah. And
this animal followed us. And so the decision was like, we saw 4 big arms, and we thought, giant squid, no idea what it does to our yellow colored RV with lights on. Let's switch the lights off and go down and switch it on later. It took about a year to realize what we had encountered was one of the large jellyfish species that has 4 large tentacles that can grow up to 8 meters. And then they have a little bell that has a diameter of 40 centimeters.
And it followed you?
It followed us.
Wow. You wouldn't think a jellyfish would do that, would you?
No. And then 2.5 months later, I was on another research vessel in a similar area in the Southern Ocean, about 100 kilometers away from the first encounter. And we had a problem with our video camera system. So we used an old-fashioned black and white VHS video recorder, and decided, because we didn't have so many tapes, we'd only start recording on the seafloor. And this was lowered again with 30 meters per minute to the seafloor. And in a similar depth, those 4 tentacles appeared, and again, they followed us down. So whatever it was at that point, we didn't know. So that jellyfish again was able to go down with us, and knowing now that the animal is only 7, 8, 9 meters long, it had to be able to actively follow our camera system for a couple of 100 meters deeper into the ocean. And that is, for me, amazing. Jellyfish is a relative of the Aurelia, the clear jellyfish you have on our shores. It's amazing.
I guess it suggests it's either predatory or curious. It wants, it's interested in you for some reason. And the fact that it follows you for hundreds of meters is, like you say, it's remarkable, really.
Yeah, it is. And this is jellyfish.
Yeah. Something that they've got a very simple nervous system. I don't even know if they have a nerve. They've got a very simple biology, haven't they, jellyfish? So for it to be able to follow you for that long is just incredible. Absolutely
it's incredible. And these are the little stories that are then told to the jellyfish experts, so they know. We also, in a caldera in the Antarctic, where we discovered a hydrothermal vent system, we had another yet undescribed football-sized dark red jellyfish that was following the RV. We always saw it in the backwards looking camera. It turned up 15 minutes, half an hour until we reached the seafloor, and we had several dives in the area, and then followed us around.
Curious jellyfish. Amazing.
Curious jellyfish.
Yeah.
Something we attracted.
Is there a deep sea species that particularly interests you? Is there one genus or one group of animals that, fascinate you, or is it just a case that everything down there fascinates you?
I think everything down there fascinates me, but the Dumbo octopuses are fantastic. I think octopuses, such as a group, are something so special, and they interact, they have the intelligence, and I think I brighten up every time I see an octopus on the underwater footage.
So what's for people that don't know, what's a Dumbo octopus?
An octopus that has very large, on its head, it has very large side fins that almost look like large ears, like the Disney character of the little Dumbo elephant.
I'm with you.
This is why they got nicknamed. And then instead they have the 8 arms, but between the 8 arms they have a web, so that when the arms go out, they almost look like a bell. So they are very odd but cute for me, humanizing them, cute little animals, and we don't know enough about them.
Are they similar to is it the vampire octopus or vampire? I know they're not actually vampiric, but it's just the name, isn't it? Is it vampire squid or vampire octopus? Are they similar to those?
They look similar, yes.
They look similar, yeah. That's incredible. Yeah, there is something about to say that it's a mollusk, and yet they are, I think they're capable of problem solving, some octopuses, aren't they?
Oh yeah, they're incredibly bright. And this is why when we want to work with them as a scientist, we need to really think what we are doing and get the right permits and keep them in the right conditions. Because ethically, you need to remember you're working with an animal that is smart.
Yeah.
And this is where, when we see them in the wild and what they are doing, we can learn from them. They are incredible.
Have you seen My Octopus Teacher?
Yes.
That opened my eyes. That film, I'll give that a quick plug, but that was an incredible film. Yeah, with you can see the intelligence in the animal's eyes.
Yeah.
Yeah, absolutely bonkers. Well, look, it's been fascinating talking to you, Katrin. It's an absolute hidden world down there, and the classic line is, "We know more about space than we do the deep sea." And I think there's a lot down there still to discover, and you're on the front lines of doing that. So, thank you for coming on the podcast. It's been great to talk about it.
Yeah, thank you, Jack, because I really like talking about this, and I think the public should value the deep sea and know about it, because you can't value what you don't know. And the deep sea is so fascinating, and it's a habitat that is under threat by us humans at the moment more than ever.
No, definitely. And you can't, out of sight, out of mind is the classic term, isn't it? And obviously,
Yes.
if you don't know it's there and you don't see it, then you're not going to care about it. So, I think it's fantastic what you're doing. But it's been an absolute pleasure. So thank you. That was Katrin Linse explaining a little bit about a hidden world that so few of us will ever get to see and explore. Hopefully you've enjoyed today's podcast. Next week, I'm going to be interviewing Adrian Brown, who is a lecturer at the Marine and Natural History Photography course down in Falmouth, the one that I used to be on. And Adrian was a lecturer there at the time. And he's going to be talking a little bit about what it's like teaching on a wildlife photography degree explaining a little bit about the course, but also the chances of... Oh, sorry, that's my phone. Shit, never mind. Explaining a little bit about the course, what the chances are of making it after the course, how to apply for these kind of things. So if you're thinking about going to uni, or maybe you're just about to leave uni, this should hopefully be a really useful podcast for you. This has been the Bearded Tits podcast. I've been your host, Jack Perks, and I'll see you next week. Cheers.